Assalamualaikum warahmatullahi wabarakatuh and good morning. So we continue with lecture about gases part 2. In the previous lecture we had learned about the properties of gases. So we have four properties. The first one that we learned is pressure, and today we are going to look at to the temperature. Okay, temperature is a property that describes the flow of energy, and this energy will flow between two objects in contact, which results in a change of states of these objects. If the objects are A and B touching together and A has a higher temperature than B, so we can say that energy flows from A to B until it reach a certain part that we said an equilibrium condition. So there is two type of boundaries. The first one is called the diathermic. So what is diathermic? And another one is adiabatic. So diathermic, if you look at to this diagram, there is two body here. For example, this one body A, body B, and body A has a high temperature compared to body B. So you can see that the energy flow from the high temperature to the low temperature, and between these two, when it contact together, there is a wall that we call diathermic wall, which allowed the energy to flow from the high to the low temperature. And another type is called a diabatic, where the thermally insulating. So the first one we call is thermally conducting, because it can change from high temperature to the low temperature. But for the adiabatic, no energy flow is permitted between the two objects. Although you put it contact to each other, because it is insulated, so the energy will not flow from these two bodies. An example, if you put the styrofoam, and we know that styrofoam is one type of insulator, so it cannot it cannot conduct the energy, the thermal energy. So this slide shows the thermal equilibrium conditions. So you can see there is a three body here, A, B, and C, where A is a block of iron, B is a block of copper, and C is a flask of water. So this ABC is at equilibrium, where we know that there is no transfer of thermal energy. In a previous slide, we had seen the condition of thermal equilibrium between three bodies A, B, and C, where there is no transfer of energy. Okay, so if we replace B with a thermometer, where we know that thermometer is a glass capillary with mercury, and if we put it in contact with A, so the mercury will show a certain length. Same thing, if we put B with contact in C, we can also see the changes of the length in the thermometer. So to summarize it, we can say that this mercury column can be used to measure the temperatures of A and C. And if the temperature for both is the same, so we can say that it will give you 0. Q is equal to 0, where there is no transfer of energy. It means it's at equilibrium. Okay, this slide actually shows the explanation of the previous slide, which related to the Zero's law thermodynamic. So in this slide also, you can see that that shows a conversion of the unit in temperature from degree Celsius to Kelvin. But you have to know that beside degree Celsius and Kelvin, you also have the unit of Fahrenheit. when you want to measure the temperature. So the conversion from degree Celsius to Kelvin is shown here, where you have to add the value from the degree Celsius to 273.15 to get the value of temperature in a Kelvin unit. Okay, that's all for part 2.